Hi students, I'm Abhishek from Vidyauru, and in today's session, the focus is going to be on number system. We are going to learn some smarter methods, some shortcuts, some tricks that will help us save a lot of time in the exam. So if you like the video, press the like button and share the video with your friends, and do not forget to subscribe to our YouTube channel, because when you subscribe, only then will you receive notifications, and to receive notifications, press the bell icon. Make sure you do that. So let's see what are we discussing. At first, we are talking about the number of factors. What if we have to find out the number of factors of a given number? Students, if the number is a simple one, if the number is small, then we can count the number of factors. Let's say the number is 12 and I have to find out the factors of 12. Factors of 12, that means all those numbers that completely divide 12, and do not leave any remainder. So when I talk about factors, I'm essentially talking about divisors. Divisors of 12 have to be found out. Factors of 12 need to be found out. So I can count the number of factors. 12 gets divided by 1. It gets divided by 2. It also gets divided by 3, 4, even 6, and of course 12 gets divided by 12. So a total number of 6 factors are there. Students, a total number of 6 factors are there that completely divide 12. Seems easy because 12 is a small number, but in the exam, if you have been given a number such as 570 or 676, then what will you do? You cannot keep counting till you reach 676. So there has to be a smarter method. I'll teach you the trick using which you will be able to find the number of factors easily. So let's think of 12 itself. What do I have to do? In the first step, I will have to express 12 as a product of prime numbers. What are you going to do? You are going to express the given number as a product of prime numbers. So prime numbers such as 2, 3, 5, 7, 11, 13, all these are what? All these are prime numbers. So the given number has to be expressed as a product of prime numbers. So what is 12? 12 is nothing but 4 into 3. But 4 is not a prime number. So I'll write 4 as 2 raised to power 2. 2 square, that means 2 raised to power 2 into 3. So the power of 2 is 2 and the power of 3 is 1. That's how, students, that's how I have expressed 12. 12 is nothing but 2 square into 3 raised to power 1, and 2 and 3. 2 and 3, they are prime numbers. So I have expressed 12 as a product of prime numbers 2 and 3. Now, how to find out the number of factors? Look at the powers. Out here, the powers are important. The powers are 2 and 1. The power of 2 is 2 and the power of 3 is 1. So what are you going to do? You are going to add 1 to each of the powers. So the first power is 2. I have added 1 to it. And I will then multiply it with the other power. The other power is 1, and of course 1 has to be added to the other power as well. 1 has to be added to all the powers and then you will multiply them. 1 has to be added to all the powers and then you multiply them. So 2 plus 1 becomes 3 and 1 plus 1 becomes 2. So 3 into 2, that means a total of 6 factors are there. And these 6 factors we had counted as well. So the answer will be the same in both the cases. You have to apply this shortcut. You must know how it has to be worked out when you have a complex number such as this. You have been given a number 441 into 448 into 529 into 576 into 625. One thing is very clear, that you cannot count the number of factors out here. It is just not possible. So what are we going to do? We are going to first of all look at this number carefully. You'll observe that these numbers 441, 4 484, 529, all these are perfect squares. So let's make it a little simple. I will write 441 as 21 square. And 484 is nothing but 22 square. Similarly, I can write 529 as 23 square. And students, we know that 576 is nothing but 24 square. Even 625 is a square of 25. So that's how I have expressed the given number. Now it seems a little simple. Now it seems a little simpler. So 21, 22, 23, 24 and 25, these are the bases. These are the base numbers. And I will now convert them into prime numbers. So to do that, I will write 21 as 3 into 7. Because 3 and 7 both are prime numbers. So 21 square will be written as 3 into 7 raised to power 2. Similarly, 22 will be written as 2 into 11. 2 into 11 and the power is again 2. 23 will not create any problem because it is a prime number in itself. So it will be 23 raised to power 2 into 24. Now students, 24 is what? 2 cube. 2 cube, that means 8. So 8 3s are 24. So 8 3s are 24. That means 2 cube into 3 raised to power 1. And of course power 2 is there in all the terms. Similarly, 25 can be written as 5 square and 5 square raised to power 2. That's how I have broken down this number into prime numbers. 3, 7, 2, 11, 23, 5, all these are prime numbers. So now I will open up the bracket and then aggregate the powers. So let me open the bracket. From the first bracket I get 3 raised to power 2 into 7 raised to power 2. Students, from the second bracket I will be getting 2 raised to power 2 into 11 raised to power 2. I'm doing nothing but simply opening the brackets. Then I have 23 raised to power 2. Then from the bracket where we had 24, I will get 2 raised to power 6. These powers 3 and 2. These powers 3 and 2 will get multiplied. So 3 2s are 6 and the power of 3 will become 2. And this gets multiplied with 5 raised to power 4. So finally, that's how we have expressed the number. After expressing the number, what I'll do is add the powers, aggregate the powers. So I have 2 raised to power 2, I have 2 raised to power 2 and I have 2 raised to power 6. So when the bases are same, the powers will get added. So the powers get added and the power of 2 becomes 8. The powers get added, the power of 2 becomes 8. Similarly, I have 3 square out here and I have another 3 square towards the end. So what does it become? The powers get added, it becomes 3 raised to power 4. Now after 2, 3, I will move to 5. The power of 5 is 4. And then I have 7. I have 7 raised to power 2. And then there is 11. So 11 raised to power 2. And finally I have 23 raised to power 2. So now what needs to be done? Students, now look at the powers. The powers are 8, 4, 4, 2, 2 and 2. So 1 is going to be added to each of the powers. So 8 plus 1, that becomes the first term. This will get multiplied with 4 plus 1 because 1 has to be added to all the powers. Even 5 has the power 4. So again I have 4 plus 1 into 2 plus 1. Again it gets multiplied with 2 plus 1 because students, 7 has the power 2, 11 has the power 2, even 23 has the power 2. So 2 plus 1 into 2 plus 1 into 2 plus 1. So 2 plus 1 will get multiplied 3 times. So I get 8 plus 1 turns out to be 9. 4 plus 1 turns out to be 5. Again, 4 plus 1 will give me a 5. So 9 into 5 into 5 into how many 3's? Into 3 3's. So 3 into 3 into 3. So now you have to simply multiply these numbers and you will get the number of factors. Anyway, let's try to do it. So 9 into 25. I have written 5 into 5 as 25 and 3 cube. 3 cube, 3 into 3 into 3 gives me 27. So students, 25 into 9. 25 into 9 will give me how much? It will give me 225. And when I multiply 225 with 27, I will be getting the answer. Finally, the answer turns out to be 6075. Nothing but a case of multiplication. So 225 into 27 gives me 6075. That means the total number of factors of the given number n are 6075. That was about finding the total number of factors. But sometimes in the exam you are asked a question where you have to find the prime factors, the number of prime factors. Now have a look at the question given on your screen. 60 raised to power 15 into 1.5 raised to power 8 into 3.5 raised to power 7. And out here you also have decimals. And please remember, over here we are talking about prime factors. We are finding the prime factors. So the basic method will remain the same. First of all, we will express the given number. We will express the given number as a product of prime numbers. So how can I write 60? 60 is nothing but 15 into 4. So 15 can be written as 3 into 5. 3 5s are 15. And we know that 15 4s are 60. But I will write 4 as 2 raised to power 2. Why? Because now I have expressed 60 as a product of prime numbers. 3, 5 and 2, they are prime numbers. And it is raised to power 15. So 3 5s are 15. 15 into 4 is 60. I have 60 raised to power 15. Now think of 1.5. How can I express 1.5 using prime numbers? Using prime numbers, I can write 1.5 as 3 divided by 2. 3 divided by 2 is nothing but 1.5. So 3 by 2 raised to power 8. And look at the next term. I have 3.5. So using prime numbers, I can write 3.5 as 7 by 2. So I'm writing it as 7 by 2 so that I get all prime numbers and the power is 7. Now what are we going to do? We are going to open up the brackets. So let's get started. I have 3 raised to power 15 into 5 raised to power 15. Now the powers of 2 will get multiplied. So I'll get 2 raised to power 30 because 15 into 2 gives me 30 into 3 raised to power 8. So 3 raised to power 8, that will be there in the numerator. Now you also have a denominator because students, 2 raised to power 8 will be a part of the denominator. So I have to write it in the denominator. Similarly, when I have 7 by 2, so 7 raised to power 7 appears in the numerator and 2 raised to power 7 gets into the denominator. So now I have 2 raised to power 8 into 2 raised to power 7 there in the denominator. So we will try to simplify it. What are we going to do? We are going to aggregate the powers. We are going to aggregate the powers. So let's look at 3. I have 3 raised to power 15 and I also have 3 raised to power 8. So first of all, I will add them up. I will add them up when the bases are same. Students, when the bases are same, the powers will get added. So I get 3 raised to power 23 into 5 raised to power 15 into 2 raised to power 30 into 7 raised to power 7. That's what my numerator looks like. Now the denominator, what is that? When the bases are same, the powers get added. So I get 2 raised to power 15 in the denominator. But students, 2 raised to power 30 is there in the numerator as well. So now they are getting divided. 2 raised to power 30 is getting divided by 2 raised to power 15. So the powers will get subtracted. In case of division, the powers will get subtracted, and out here you will be getting 2 raised to power 15 in the numerator. Only 2 raised to power 15 will remain in the numerator. So finally the number looks like 3 raised to power 23 into 5 raised to power 15 into 2 raised to power 15, because only 15 power of 2 was left, into 7 raised to power 7. That's how I have expressed this complicated number as a product of prime numbers. 3, 5, 2 and 7 are all prime numbers. So when you are trying to find the number of prime factors, all you have to do is add the powers. Now look at the powers that you have. You have 23, 15, 15 and 7. The powers of prime numbers have to be added and nothing else. You are not supposed to increase the powers by 1 and then multiply them. No, simply add them up. When you are trying to find the number of prime factors, that is the shortcut. So adding the powers, 23 plus 15 plus 15 plus 7. I have added all the powers and I get 15 and 15, that is 30, and 23 plus 7 also gives me 30. So 30 plus 30, the answer turns out to be 60. So the number of prime factors are 60. So our method helped us a lot, saved us a lot of time. Now let's look at a tricky question which was recently there in the exam. The question says n is equal to 12 cube into 3 raised to power 4 into 5 square, and now we have to find out the number of even factors. We are only supposed to find out the even factors and not the complete number of factors. Only even factors have to be found out. So let's see how to go about it. The basic method will remain the same. I will write n as a product of prime numbers. So 12 can be written as 2 square into 3. 2 square is 4, 4 3s are 12. So 2 square into 3 raised to power 3 into 3 raised to power 4 into 5 raised to power 2. Now look at the numbers you have. 2, 3 and 5. You have 2, 3 and 5. All of them are prime numbers. So now let's open up the bracket and aggregate the powers. So what power of 2 will be there? 2 3s are 6. So 2 raised to power 6 into 3 raised to power 3 into 3 raised to power 4 into 5 raised to power 2. Now we can further aggregate the powers, and what does it become? 2 raised to power 6 into 3 raised to power 7 into 5 square. So now n, the original number has been written as 2 raised to power 6 into 3 raised to power 7 into 5 raised to power 2. It is still the same number. Students, it is still the same number. It's just that now we have simplified it and we have written it as a product of prime numbers. So now let's find out the total number of factors. Although we have to find out the even number of factors, but for that we will have to look at the total number of factors first. And how do we find the total number of factors? We will look at the powers. The powers are 6, 7 and 2. The powers are 6, 7 and 2. So we'll add 1 to each of the powers. So the first power, 6 plus 1, I will add 1 to it, and then I multiply it with 7 plus 1, and then I multiply it with 2 plus 1. So what have I done? I've added 1 to each of the powers. and I have multiplied them. So now I get 7 into 8. Students, now I get 7 into 8 into 3. 6 plus 1 gives me a 7. 7 plus 1 is 8. So 7 into 8 into 3. That means 56 into 3. 7 8s are 56. So a total number of 168 factors are there. Students, that is not the answer. Till now we have only looked at the total number of factors. Now from the total number of factors, that is 168, if I subtract the odd factors, then I'll be getting the even factors. Listen to me carefully, because this is the tricky part, and that's where most of the students make mistake. Think of these 168 numbers. When I say that 168 factors are there, that means total number of 168 factors are there. That means there are 168 numbers. Students, listen to me carefully. There are 168 numbers which divide this number completely. So out of these 168 numbers which divide the given number completely, some will be odd and some will be even. From the 168 total number of factors, I will subtract the odd factors, and when I do that, I will get the even number of factors. Through that, I'll be getting the even number of factors. But look at how to find the odd factors. Look carefully. Odd factors will be generated only by 3 raised to power 7 and 5 raised to power 2. Students, odd numbers will get generated only by the combination of 3 and 5. 3 and 5 both are odd numbers, so only through the combination of 3 and 5, only through the multiplication of various powers of 3 and 5 will you get odd factors. So a combination of 3 and 5 only generates odd factors. So focus on the powers that 3 and 5 have. Other combinations will generate even factors. Look at the combination of 2 and 5. Students, 2 and 5, if they are multiplied, they give you an even number. Different powers of 2 and different powers of 5, when they are multiplied with each other, you will get an even number. Similarly, if you look at 2 and 3, the other combination, when various powers of 2 are multiplied with different powers of 3, you will again get an even number. So odd factors or odd numbers will be generated only by 3 and 5, only by the powers of 3 and 5. For 3 is 7, the power of 5 is 2. So the same thing, I will add 1 to the power of 3, 7 plus 1, and I will add 1 to the power of 5, that means 2 plus 1. What have I done? Again the same thing. I will look at the number of factors that the powers of 3 and 5 will generate. So the powers of 3 and 5, how many factors will they generate? 7 plus 1 into 2 plus 1. The same process, add 1 and multiply. That means 8 into 3. 8 into 3, that is 24. And all these 24, students, all these 24 will be odd factors because they are getting generated by the multiplication of 3 and 5. 3 and 5 are both odd. So only when you multiply an odd number with an odd number, that you get an odd number. So 3 and 5 both are odd. So together their powers generate 24 factors, and these 24 are, please remember, odd factors. These 24 are odd factors. The total number of factors was 168. The total number of factors was 168. From that, I'm subtracting 24 because all these 24 were odd as they had been generated by using 3 and 5. So 168 minus 24 gives me 144. That is the final answer. We have taken some time to understand this question because it was tricky, it was difficult. Students generally face a problem where they are not able to understand how odd factors get generated. I hope you have understood that. So if you like the video, press the like button and share it with your friends. Thank you so much.